I would argue that we know as much about how golf shafts work as any golf shaft manufacturer out there. But there's a perception, and we understand that, and we fight that OEM shafts are not as good as aftermarket shafts, and we always fight that. But I would argue there's no company out there.
Well, usually it's true.
Welcome back, everybody. No putts given. How you living? Tony is back. Chris, I'm back. And again, for the third episode in a row, we have somebody far more intelligent, inspiring, and knowledgeable than either of us, Paul Wood.
That's always good.
Hey, how's it going, guys?
Paul, who are you? What do you do?
Ask myself that question a lot.
Who did we get?
Yeah, I mean, because in town there's a Paul Wood florist, and I doubt you own a floral company in Fort Collins, Colorado, but...
That is not me. There's also the Middle East correspondent for the BBC, which sounds like a fun job. He's a Paul Wood, and there's a blues guitarist, which is a job I would love. But no, I'm the VP engineering at Ping Golf.
That's good.
I mean,
it's not the worst thing in the world.
but it started with solar flares.
Exactly. So I went to University of St. Andrews. Hopefully, after 16 years in America, hopefully you can still tell I have a bit of an accent. But I'm from the UK, went to university in St. Andrews, studied mathematics, stumbled into a PhD doing solar flares, which was really good fun. Basically, explosions on the sun. Think kind of volcanoes on the sun. So try to figure out the mathematics of how it happens and why it happens and what happens when it does happen. And then just always been sport mad and wanted to work in sports, and sort of thought, who needs somebody who knows about solar flares in the sports industry? How about a golf company? I mean, so I figured that maybe you would need some mathematical kind of know-how in the golf industry, and I didn't know much about it, but as it turned out, I got lucky, and Ping were looking for someone with my kind of skill set.
You said you kind of fell into how does one fall?
Solar flares
Yeah, how does
expert.
one fall into solar flares? Like, what part of math and like, oh, okay, 2 + 2, explosions on the sun. Let's figure out why that. Let alone a PhD program, which is super intense. So it's not like this was some kind of like weekend hobby, building, trinkets in your garage. I mean,
Started in the
yeah,
basement,
you're like
yeah.
all in PhD level. The whole idea of a doctorate, right, of a terminal degree, is to add knowledge to that part of the world that hasn't ever been added before. And you're like, solar flares.
Yeah, and like you said, a PhD is you're studying something. The whole point of it is you're doing something no one's done before. So you become the world expert in a field this big. So when you do your degree, it's somewhat broad, and then suddenly you're in like this really deep, really narrow field. But yeah, I can't say I grew up as a 12-year-old in rural Herefordshire thinking I see my life studying solar flares. But I was always good at mathematics. I tried my best to get out of it. I actually got accepted to St. Andrews to study philosophy and economics, and somehow I got pulled back into the math side of it, and did pretty well, and ended up doing a master's project, and then tried to leave again. And I had a position to do a master's degree in writing about science, and that was my big plan. I was going to be a writer and write about science, and I got offered the PhD by a professor I knew pretty well, and I'd done like a master's project on the sun, and that happened to be the solar flares because St. Andrews is a world center for that. There's a lot of professors working on the mathematics of the sun, and so when they had a PhD come available, they called me and they said, the funding's there, do you want to learn how to research? And at the time, probably most importantly, they said, do you want to stay in St. Andrews for 3 more years? And you guys have probably both been there. It's a pretty amazing place, and it's a hard place to leave. So I had 3 more years in St. Andrews, and it was
Are they hell-bent on learning about the sun because they so rarely see it?
That's true.
Is that part of the appeal?
The irony of studying the sun in Scotland is not lost on the group. Yeah, I have to get a satellite, with millions of dollars of technology to get the data just to look at the sun from Scotland. But yeah, it was it was a great experience, and I loved it. I never had intentions of spending my life being a professor and being a math researcher, but the idea of I'm going to get taught how to research and I'm going to do something that no one's ever done before. And then you get into the PhD and you realize there's something no one's ever done before. It's something no one else really cares that much about, but it was still cool. It was
Those
still,
those two tend to coincide fairly often. Yeah.
So, so how does a doctorate in solar flares translate to a career at Ping, a company known for making golf clubs?
it
I'm
seems like a bit
struggling
of
to
a
find
stretch,
that.
doesn't it? I mean, I was studying the mathematics of basically the mathematics of how particles move around on the sun in like one small subset of it. So I was solving Newton's equations of motion, obviously solving them for particles going along at a fraction of the speed of light on the sun and at incredible temperatures. But when it comes down to it, I actually had made a code that was working out how to solve those equations. And when my first project at Ping was, we'd like you to build a better golf ball model, and ball flight is solving the equations of motions. Obviously, it's different things. Instead of electromagnetic forces, you're looking at lift and drag and gravity, but the equations are the same. So all the code that I built for my PhD, I ended up just kind of lifting and placing, and now we have a ball model. I just need to tweak the parameters. And as it happened, TrackMan had just come along the scene when I started at Ping, and so I used a bunch of TrackMan data to build my model. But it was the same equations, so I was telling all the guys at Ping, yeah, it's basically just the same as solar flares, but just with slightly different numbers in the equations. But I mean, honestly, it's learning how to research and learning how to research mathematical stuff, and that ended up being relevant. I mean, as you guys are aware, like collecting good data on humans hitting golf shots is very mathematical. The impact dynamics between a club and a ball are very mathematical. Golf ball flight is very mathematical. Aerodynamics. So it's all that general skill of learning how to research. That's how it ended up.
Research and math.
Research
Lots of
and
math.
math. So why Ping, or like what was Ping's interest in you? I see how the math connects to Ping, but are they Ping's looking around going, we
I mean,
think,
somewhat luck. Yeah, somewhat luck. Ping had a mathematician working on staff who'd retired a couple of years before my application landed on the inbox, and and so they just started thinking. John K. Solheim, who's now our company president, but he was the guy who hired me at the time. He had my job. He was VP engineering at the time, and he just started thinking about looking for a mathematician because this guy they had who retired had been pretty useful and helped solve some problems. And my email came into Ping Europe, and it got happened to be forwarded on by the right lady who said to me years later, I don't normally bother forwarding things like that, but I don't know, something about your resume looked interesting, so I forwarded it to John Kay. So there's a lot of luck along the way, and I can't say that I knew much about the industry, so it wasn't like my whole life I was set on working for Ping. I think I got lucky and found a really cool company, but I applied to a couple of other golf companies at the same time, and Ping were the ones that got back to me.
so
And I
if
remember,
she doesn't,
Did you play a lot of
yeah, if she
golf?
doesn't forward that email, you may not end
yeah,
up at Ping.
and
You may
John Kay
have,
never even sees my resume, and I
yeah.
don't. I'd already somewhat given up at the time that Ping interviewed me. I had offers for a couple of jobs working in the city of London, being at quantitative analysis, which would have been a whole different pathway. The guys that make models that predict how the stock market's going to go and that kind of stuff. I could have been doing that instead of golf. I don't think I'd have enjoyed it quite as much.
Did you play a lot of golf before? Was that part of it? Like, hey, I play
Yeah,
golf,
I
or was it
played.
just sort of a passing interest?
I played some. Compared to a lot of my colleagues in engineering at Ping, I feel like a bit of a fraud who never really, like, never took the time to get to scratch or anything like that.
That's a
I've
tough crew, though. That I
I've got
mean,
colleagues who played
It
majors.
really
Yeah,
is. Yeah.
I mean, you got Marty Jerkson, you got Bacon, you got some pretty good
Travis
players.
Millman, Eric. Yeah, there's loads of the guys that play off not just
Yeah.
scratch, plus four,
Eric's
plus five.
Eric's Eric's no hacker, right?
Right. And I played off when I applied to Ping. I played off about 12, and I still play off about 8. And so in ping world, I'm a hacker, and then I realized actually in the real world I'm an okay golfer, but 8 is like you might as well be a beginner at ping. So I played. Everyone plays in St Andrews. I don't know how many people know this, but if you live there, it's free. So you can play the old course for free whenever you want. It's quite a deal. So everyone plays, and it's quite laid back. And I played lots of other sports too, but I enjoyed it, and I played it enough to think I bet that golf companies might need someone with my skills, and I bet it would be an interesting challenge. And that's what's kept me in it. It is an interesting challenge. We haven't solved it all yet. It's 15 years in, and we now have, I don't know how many, 8 PhDs on staff and a bunch of people with master's degrees, and we still haven't got it all figured out.
Well, I think that
So it's
yeah.
interesting. I want to kind of transition to my first time at Ping, and this, I think it kind of ties in with what you're talking about with kind of the research angle to a large extent. But I sit down for the first time in the conference room, expecting to start with just jump right into products, and I was in there with I think you and Marty and Eric, and kind of the first thing that was said is first and foremost, Ping is a knowledge company. Not necessarily a product company that the knowledge leads to products, but it was kind of an interesting way to think about what you guys do. So I was wondering if you could kind of talk about what that means and how that influences how you do things on a day-to-day basis.
Yeah, I remember that distinctly. And it's always made, maybe because of the research background, it's always just made sense to me. And then you sort of realize this is not how most companies work. It's how most universities work, that you're researching to build the knowledge base, right? That you're trying to understand in solar flare world, the university is trying to build up our knowledge of how solar flares work. And my little piece of it is this big. And then you add up everyone's little piece of that. And what I learn about solar flares helps the next person and the next person. And that famous um, Isaac Newton quote, if I've seen further than others, it's because I've been standing on the shoulders of giants. That's the idea, right? The new person coming in is standing on the top of this knowledge pyramid and now can do more stuff because they understand everything. And so we went through this transition of, instead of everything being about I'm going to do the next driver, I'm just going to do my thing for the next driver, and I'm going to do the next iron, I'm doing my thing, and it'd be a whole bunch of little kind of pods of people working independently. The real power is if we can kind of make sure that everyone understands what everyone else knows. So when I learn something about golf club aerodynamics, how do I best disseminate that to the rest of the team? Because Ping went through this transition of Carsten used to do everything, right? That back in the old days, Carsten was the knowledge environment. He knew, and people would feed it to him, and everything would go through Carsten Solheim, and he was the chief researcher, the chief tester, the chief designer, and the chief marketer. Well, we're too big a company to do that now. We have much more people. It's very in depth. So no one person has everything. So we really made this, and John Kay was the one who kind of said, "Yeah, I want you guys to build this. Like you can go away and spend the time making this happen." And so myself and a bunch of the other guys really made it a big point of, let's rearrange how we store all of our information. Let's build this system where, as an engineer, you're feeding into the knowledge we have and try to put as much into that as possible. And then when the guys come into like, I'm designing the next driver, they're going to the knowledge well to pull from that, rather than I'm just going to kind of do my own thing and kind of reinvent the wheel. So it doesn't sound like a big shift, but it ended up being quite a big just shift in mentality. That's the aim, is we're trying to build knowledge that applies to the next 20 years of clubs, not just what's going to apply to next year's golf club. So how do we?
Does this kind of help explain why? So, like, we've talked before other articles about Enzo, which is 3D basically mapping shaft analysis. There's 3 units in the world. 2 of them are owned by Fujikura, which makes sense. They're a shaft company. That's what they do. But the other unit is owned by Ping, right? So, I mean, does that kind of fall in line with this idea of, hey, if Fujikura knows A, B, and C about shafts, we want to know just as much as they do. So we're going to buy this system. Oh yeah, we're also going to hire a guy like John Oldenburg, right, who has decades in the industry, Aldala, and then LA Golf for 28 minutes or however long he was there, and then over to Ping. I mean, this guy's an industry shaft expert, but now he's working for a company that doesn't make shafts.
Yeah, I'd maybe argue that point slightly. We do make shafts, or at least
Then
we
argue it. Argue with
design.
me, Paul. Let's argue.
Well, so I would argue that we've always been proud of our shafts. So you mentioned Marty Justin. He designed some of our shafts for a few years. Bringing John in takes it up to the next level. Buying Enzo took it up to the next level. But I would argue that we know as much about how golf shafts work as any golf shaft manufacturer out there. But there's a perception, and we understand that, and we fight that OEM shafts are not as good as aftermarket shafts, and we always fight that. But
Mm-hmm.
I would argue there's no company out
Well,
there.
usually it's true. Right?
I'd argue
That's the
there's no
hard
company
part, right? Because
that understands how the shaft works as well as Ping, and I'd include in that
yeah,
even Fujikura and Graphite Design and Mitsubishi, and bringing John on and really helped that a lot. But you know, Marty's forgotten more about shafts than most people out in the industry. Enzo itself, we've had 10 years of collecting data. I mean, who invests $250,000 in a motion capture system for golf unless they're really serious about the research side behind it? I mean,
or
we've
really
had
stupid
a
and
lot.
have a lot of money to waste, right? Like, yeah, I mean,
That's
it doesn't
that's
it
a
doesn't
fair
make sense.
point
So
too.
with that, like, but I mean, do you think it's fair to say that? I mean, because that's something that has always been very understated about Ping. The Ping's version, Ping's tour shaft, there'd be, it'd be kind of this metallic silver, pretty understated graphics. I think it was UST Mamiya. You guys did a lot of collaborative work because obviously you need a manufacturer for those parts. But in terms of the quality of the product, the design of those shafts, is it fair to say you would put those on par with anything that's out there in the industry, regardless of price point?
I would, yeah, and admittedly, I work for Ping and I may be biased on that, but I know how much goes into it. It's not, the conversation is not, hey, just give us a shaft that we can slap Ping on there and we'll be good. We put a ton of effort into designing, collaborating. We do, I mean, it's a collaboration. The tour shafts have been a collaboration with UST. They do a great job with us. We demand, I think, arguably higher quality of our shafts than of the aftermarket side of it. So yeah, I have confidence that when you buy a Ping shaft, it is every bit as good quality as any other shaft out there. That's a big statement because our shafts are not as expensive as a lot of other shafts, but I know how much we put in behind it. We have people like John Oldenburg and Marty and myself and Dr. Eric Henriksen and the power of the Enzo system behind all that. So there's a lot of stuff goes into those shafts. I mean, and Enzo's been,
So obviously, I mean,
go on, sorry.
you're doing a ton of research, but we know that you're going places where others aren't going. Right, as Chris mentioned, you have one of three Enzo systems, the only major OEM with one of those. But what are you hoping to gain in practical terms? What is realistic given USGA regulations? Never mind the fact that they're talking about maybe rolling stuff back. Like, what does performance improvement look like to you at Ping, and kind of what is the roadmap and how you get there, and ultimately what should golfers expect for your efforts?
That's a great question. It's the big question too, and it will be interesting to see what happens with potential USGA regulations down the line. But just like you guys, we're going to have to wait and see what that looks like. We're getting to we have got to the point where we've maxed out on certain regulations on golf, but we haven't hit all of we haven't hit all of the outsides of the boxes. So we still see some room to improve on some of the basics, like can we squeeze more distance through ball speed, through optimizing launch and spin, through higher moment of inertia. We still have trade-offs we have to make. Moment of inertia versus CG location on a lot of clubs is a trade-off. We can still push at that trade-off. We're not totally maxed out on the USGA limits. I think with things like shafts, I think we all understand that the shafts, it's a there are some shafts that work for more golfers than others, but a lot of it is finding the way to link the right player to the right shaft. It's a club fitting or club selection issue, and as much as we've led the industry over the last 30 years in that, the number of people who get a really good club fitting is still way lower than we'd like it to be. And I think there's still a lot of work we could do to figure out how do I predict, what is the best possible shaft for Tony Covey versus the best possible shaft for Chris Nickel and versus for me. Um, I can sort of answer that question right now, but not as well as I'd like to. So I think there's a lot of research there. And we now, technically speaking, we own two of these systems. So we've built our own new system that's kind of Enzo's child, which we're going to be calling Focal, sort of fast optical capture analysis lab. But the Focal system will be our new Enzo that we've built ourselves. We sponsored a PhD with a university in the UK, and we have our first system up and running in the UK, and we're going to be adding a second one in Phoenix. And so now we'll have two. Well, we do have two of the world's four systems. So, no, not that we're trying to leave Fujikura behind, but just we are continuing to invest and build. And it didn't do everything we wanted, so we're trying to add more to that system. So watch this
Meaning
space. I think
Enzo didn't do everything.
I think that might have been a world
Like
exclusive.
Enzo
Actually.
didn't do everything you wanted. Yeah.
Yeah, and no
I
system does
I mean
everything
that
you want. Enzo's amazing and has been revolutionary for us. How accurate that system is and how reliable it is amazing. But we can always do more. Can the cameras get faster? Can we add more things? We wanted to add force plates to the system. We wanted to potentially do a little bit of body capture, but without going into the full bodysuit. We want to look more at impact itself. For the viewers and the listeners, Enzo works at 720 hertz. That means a data point 720 times a second. But that gives you less than one data point of impact. So we've been looking at some stuff with 20,000 frames a second cameras and trying to tie them together with the Enzo system so that you can look at
jeez.
it's fun stuff, right? Um, so you get 10 or so data points during impact, and then you can really start to look at what actually happened during the impact. So I was looking at some data we took with wedges with 20,000 frames a second cameras last week and looking at how the angle of attack changes through impact and how does some of those things, how can you actually see turf interaction before impact? We can't quite pick that up with a 720 hertz system. So there's things we can still do. If I could snap my fingers, I'd have the whole camera system at 20,000 hertz, but that gets really data intensive. So we're still a little way off.
That's a whole other thing, right? You collect the data, but now you have all this extra data or new
It's a
data,
huge,
and you've got to figure out how to
and
manage.
that's actually what maybe we're kind of going too geeky right now. But that's the challenge we're working through right now with our new system. Is if we're going to have one in Phoenix and one in the UK, and potentially in the future one in Japan, how do you tie all that data together without it slowing the whole thing down? You need part of the beauty of it is, and you've been on there, Tony, right? You can hit a shot. Maybe you wait 10 seconds for it to process the data, but then you can hit the next shot. And if you have to wait 5 minutes before you can hit your next shot, that gets a little tough. So that's part of we're generating so much data that you don't want to just drown in it.
Well, and that kind of leads to, I remember one time, maybe Tony, you were telling me this, or Paul, you just, whatever the case was, it kind of reframed how I thought about ping as a company. And I think there's examples of different things that companies do that help shape people's opinions about it, right? Like we do our industry-wide surveys every year, and people, what they associate ping with and other companies. And this one dealt with an intern that was using like a leaf blower to test the durability and weight of head covers, right? To make sure like they wouldn't blow away and this and that. And I wanted to pick your brain, like, what are some of the either super bizarre things? Because you guys, if you're really exploring information and knowledge,
Do
you
weird
try
stuff.
weird shit that never sees the light of day. And then you probably try some stuff that maybe did lead to something substantive. So I'd love to hear about a couple of like the all-time, goofiest, most bizarre tests or things that you guys have done that again, because no other company would do this stuff, right? This is stuff that Ping does because it's Ping.
Yeah, no, that's good. The one you mentioned was a fun one. That's one of my favorites, and that was, we'd noticed that our head covers had got lighter over the years and would, in a big wind, start to blow away. But because Ping is who we have to prove something's better. Like that's our CEO and our president, John Soheim and John Kay. That's the mandate from them. You have to prove to us why it's better. So we sat down and thought, how do we test that? Well, we can using these we have these fancy leaf blowers that you can dial up the speed, the wind speed to whatever you want, and we would see how fast do we have to get the wind going before the head cover starts to move. So these poor interns are there on the range. Um, they're on the range dialing up wind blowers, but it did show that we could actually prove a difference, which was that was the that was the plan.
So what else? What else have you done like that people maybe hadn't heard of? Because like I said, that changed how I viewed ping. So I'm like, man, if they would go to that length with the head cover, I have reason to trust what they say about MOI or about why they designed a certain pocket on a bag or this
Yeah.
level of intentionality. It's fun and it's goofy, but I also think it's indicative of kind of what you guys do and who you are a little bit.
Yeah, okay, I'll give you a couple of examples. I'm trying. So, probably our most famous one that some people might have heard of is when we do our robot testing. We'll do the standard robot testing where you hit from dry conditions. We have a whole water system where we can kind of spray the ball with water and test in slightly wet conditions. But that doesn't get you really where you need to get to simulate what's it really like hitting out of grass. So we will have interns, bless them. I've done the job. It's the worst job of paying. Taping individual blades of grass into a line so that we can put a line of grass between club and ball. And of course, every shot that thing gets blitzed away. So you need a line of grass for every shot you're going to hit on the robot. So we'll get a team of interns. We we have one of our guys grow his grass just to a certain length.
So awful.
It's a character building job. It's a very wax on, wax off kind of job. But it really works. And we've tried other things. The USGA uses kind of a wet newsprint to simulate grass. And it does okay, but it doesn't do as good as grass. And it's really difficult to take the robot out and hit out of the same grass conditions every time. So the best way to test it is to get interns to line up grass. That's a good one. But that's a really serious one because that gives us great data that we couldn't get any other way.
And note
Um,
it's all interns doing this for
it's it's not
you know.
all. I mean, it's more. It's not. I remember having to do the job when I started. It's a sort of it's a rite of passage. If you started at Ping, if you're a junior engineer, you get to do it once until you can figure out how to hand it off to someone else. My first patent at Ping was on golf tees. And talking of things that never see the light of day, I was asked to study how much of a difference does a golf tee actually make, and can we measure a difference? And again, like the best way we could think to do it was to get the robot, and we used our $100,000 high speed camera because it was the best way to actually truly measure this stuff. And we built a little box that we filled with soil so the tee could sit in the soil, and then we would put that on top of the robot's teeing area. And every single shot, you would have to get the tee in the perfect spot so it wasn't too far forward, too far back, compact the soil down. And we hit shots on the robot all day long with, I think we tried 15 different brands of tee while we tried to understand, A, does it even make a difference? And then if it does, what is the thing that makes the difference? And so after all that, we were able to show, yeah, the tee can make about 200 or 300 RPM difference. And we understand now why and what makes the difference. So we filed a couple of patents. That they were my first ever patents of Ping. And then we sat down and looked at the business case for like developing our own tea and went, yeah, this isn't going to work. And so those patents are not far off expiring now. But it was a cool experiment, and we learned something. We added to our knowledge environment, and it was a weird test, but it never actually saw the light of day, unfortunately.
The one that continues to blow my mind, Paul, that not only have you changed how you do a simple little thing because of it, but that you even found it. But can you talk a little bit about the changes you guys made to where you position the shaft labels on putters?
Yeah, that was a good one. So I'd been interested in the idea of using eye tracking technology And part of it was a chance meeting with a sports psychologist who said, yeah, like you can really, if you use eye tracking technology, you can really see what players are focusing on, and if you can get a putter in a player's hands that allows them to like focus on what you want them to focus on or what they want to focus on, the alignment feature, whatever it is they use. And some people use the top rail, some people use a line, some people use a dot. But he said, whatever it is, if you can get that person focusing on that and not getting distracted by anything else, they will putt better. And the term's called quiet eye. You get your eye quiet, which means it's not dancing around and it's not being distracted by something. And then you get your mind quiet, and there's a lot of science behind how that helps players putt better. So we ended up buying this eye tracking software, and it's glasses that there's two cameras, one that looks out, so it sees your field of view. So if you move your head, it changes your field of view or shows your field of view. And then one's looking into the pupil, and you can calibrate it, and you can actually, in the software, see exactly what someone's focusing on. And you can watch live as where people's gaze is dancing. So we were doing this big study looking at what do players focus on. If I put a big mallet with loads of alignment features versus, a really simple blade with nothing, how does it change players' gaze patterns? And then talking of unexpected results, in the middle of it all, we found that like 4 or 5 players in a row, their gaze kept moving up to the shaft. And like right in the middle of their prep for their stroke, their gaze keeps moving up, and they're seeing the little shaft label we have. It just shows you it's up by the grip. It just shows you, is it a straight, a slight arc, or a strong arc putter? And it's not there for players to look at. It's there when you're in the store to see which putter's going to work for me. But it was distracting players. So we just moved it and put it around the back of the shaft, and voila, problem solved. But we would never have even seen that if we hadn't had this eye tracking software. And now we don't put anything on the front of the shaft for that reason. Little things, marginal gains, we call it. These little, if you can make a bunch of things 1% better, overall it adds up. If you make 10 of those little improvements, now you've got a 10% gain. So
When you talk,
So what is the target then when you go to launch a new product, right? And you said, right, your mandate is you're not going to release anything unless you can show that it's better than what you already have. But is there a target? Is it 1% 10 times or 10 places, 1% 5 places, 5% twice? Like
yeah,
what's the
it's
formula
hard to
there?
put numbers to that. I think when we sit down and kind of scope out the project, I mean, the aim is like, the aim every time is, can we find a way to revolutionize the industry with this product? And at some point, you know, sometimes you think you really have something that's huge, and often you have to kind of accept that, okay, this is going to be more of an evolutionary update. And that's when you start to think of like, well, what are the little things we can add to it? And it's tricky. The target is always as much as you can possibly get in there. And then the way product development goes, you get your initial prototypes that are usually amazing, and then you try to hang on to as many of those gains as you can as you get through the nitty gritty of product development and having to scale up the production and all the little things that can go wrong and do go wrong. And so, one of our designers last week kind of mentioned, in his head, it's like, if I can hang on to 60, 70% of the gains I think I made at the start of the project, by the end of the project, I've done pretty well. And then every now and again, you get one where you've hung on to like 99% of the gains we thought we were going to make. And that's usually when you get the home run. That's the one that, just for whatever reason, it came out exactly as we intended. Like, you're baking a cake. It just, for whatever reason, it came out perfect. And so it's hard.
can
We
you
don't
think
have.
any products that kind of exemplify that, where you were able to hold on to the vast majority of the improvements that started at the end? You're like, man, boom,
Yeah, I think
G400, boom,
G400 in particular,
like
G400 LS
hydro
Tech.
pearl finish or something.
Yeah, I think the G400 LS Tech would be a perfect example. That it is a little bit of a unicorn. It's an amazing product. The G400 series in general, we were super excited about. We knew it was good. We knew we'd held on to a lot of the things that we knew on paper had managed to make it through the market. But for some reason, the LS Tech just nailed it just that bit better than everything else. And, to the point where it's been difficult now to get it out of some players' hands because it's so good. And and that's happened sometimes that you get a little bit surprised. Like we knew it was good, but there's a couple of things about it that we're like, okay, we need to go back and that we must have missed a little something. That it's an extra special secret sauce. And I think with blade irons sometimes it's a little similar that you get one that just really nails it, and then it's difficult to understand. Well, what is it specifically about that blade iron? And the technology is kind of similar. The moment of inertia is kind of similar. Our S55 iron has a little bit of that. There's still Matt Fitzpatrick just won the U.S. Open with those irons, and they're great irons. But there's no particular reason why he's playing those and not iBlades or I-59, say. So it's an interesting. You see it sometimes there with irons or wedges. And some of it is.
Yeah.
iBlades have been great too. Yeah, S55s and iBlades have really been sticky. They stayed in players' bags, which is great. And I think players tend to stick with irons a bit more. You build that level of trust, and it's a whole set of irons. And whereas with drivers, most players are a bit more okay to shift into the next thing.
Tony, you have a question. I know you have a question.
Do I have
You
a
always
question?
have questions.
Yeah,
I have.
question.
So
Yeah.
I'll ask my question first, and then you can ask yours about sports, greatest of all time, bizarre information. Oh, see, yes, exactly.
Yeah, that's-
Human testing versus robot testing. We get this question all the time, and people are like, "Why don't you test on a robot? Why don't you test on a robot? Why don't you test on a robot?" And we tell them, we don't test the way that we do on a robot because it isn't the most valid way to assess performance based on how consumers purchase equipment. And we talk about it all the time, but from your perspective as an industry person, why don't we test with a robot? Why does that make sense that we don't test ping equipment on a robot when we're doing our player testing?
It's a great question. I think the robot's super valuable. Right? We've had Pingman since the 70s. We still use Pingman. We're on Pingman 6 these days. He's been through a few wardrobe changes. And the robot's super valuable, but the robot is the acid test. Like we're designing clubs that are supposed to perform better on a golf course, right? So the acid test is how players use them on the course. And ultimately, it's still our biggest marketing tool. Is if we sell you a driver and you are now out driving your buddies where you didn't used to, that's the real performance test. So obviously we can't just, launch a driver and then wait 2 years and watch everyone golf and then decide whether it was any good or not. We have to work backwards and try to control some variables. But ultimately that's what you're trying to get to, right? That's the real performance goal. And we can do a bit of that through Arcos now, of just looking at where did players actually go on a golf course, and we are looking more at that. But that's a lagging indicator, right? You've got to launch it before you get that data. So we need something we can do ahead of time. So then, the reality is golfers, humans, hitting our golf clubs is the performance test. And so as messy as it is, and I think that's the phrase I've used with Tony in about 100 discussions we've had, like humans are messy, but you sort of have to work with that because that is the performance. And the one thing the robot can't do is it just does what it's told. So it can't be, the robot's not trying to find a fairway. The robot's just doing what we tell him. And if you put a club in his hands that is heavier, is lighter, the shaft is different, whatever, the robot just waits for us to tell it how to hit it straight again. It's not, it doesn't have that reaction players do. Which is what makes it amazing for controlling variables. So if you have a single variable test, and I want to say, I'm just going to isolate everything else, and I just want to know the effect of, say, club loft on what happens to ball flight, or I want to know for this golf club what happens when I hit it a half-inch high on the face. The robot can answer that question, and players can't. The best player in the world, you can't say just hit one half an inch high on the face, please. Plus or minus a 20th of an inch. And by the way, keep everything else identical to what you did last time. Right? Not the best player in the world can do that. The robot can. So the robot can be super valuable for, like, if you want to map out a face. If you wanted to incorporate robot testing in your most wanted stuff, that would be probably where I would start. Is doing some sort of face mapping, and you can look at how does it perform on heel and toe hits relative to center hits? The robot can answer that question great. But if you just want to know how how does this perform for all the mess that humans bring to it, like you have to do human testing. The robot can't really answer that question. You would have to do human testing to feed into the robot testing, which would kind of defeat the object of doing the robot testing. So,
Right.
so we do both, and we can, and we do, and we do. We feed a lot of our human testing into the robot testing, but but if it's a choice, you you can't take out the human testing. You can't take out the messy humans from golf. Otherwise, we have robot golf, which I
Here
don't
we
think
are.
you
We're
watch.
messy.
Exactly.
If only. If only I could take out the mess from
Right?
my game. I'd be probably
Right? It'd
bored.
be something.
All right, so last thing, Paul. I've learned over the years that you are a fountain of potentially useless knowledge as it pertains to all kinds of sports and the athletes that play them. So I'll put you on the spot here. Greatest athlete of all time in any sport. Go.
Well, Don Bradman, who nobody watching this will have heard of unless they're British or Australian. It's a difficult one.
Yeah, you could have just made that up.
You've heard me say that before, I know. So, greatest athlete is maybe a little bit different to greatest sportsman. How do you define these things, right? The greatest in their sport. Don Bradman was a cricketer in the 1930s that played for Australia, who his batting statistics, I'm trying to think if I can switch this into a baseball analogy for the American listeners. He averaged, in cricket terms, he averaged 99.94 every time he went out to bat. The next best player in the history of cricket averages about 60. So I don't know, what's the best batting average in baseball that any major player's ever had? Like
400.
0.400.
Yep,
It's
400.
like someone going out and batting 600 for their whole career. And that's how much better his stats are than anyone else's. So in cricket world, and cricket's a major sport. I don't not played in America much, but a couple of billion people around the world play it. He's so much better than anyone else that ever played cricket that there's no one that can claim that in golf because there is a debate, which is kind of good, and that's part of fun, right? And is it Tiger? Is it Jack? Do you bring in Hogan? Do you all this kind of fun? But the one thing you can say with golf is it's not obvious who's the greatest golfer of all time. But if you ask 100 cricket fans, they'll all say Don Bradman. I'm quite the nerd.
I don't think I know
Only
100
know
crickets.
myself. But there's other guys I think that would have a great claim to it. But it is that who elevates himself so much further above than anyone else. You get Ed Moses in track and field, the American hurdler who he ran 180 races unbeaten, which covered like 8 years. He'd have a pretty good claim. But that's a very niche sport. There aren't many people playing, well, there aren't that many people doing 400-meter hurdles. I'd like to write
Or
a
a
book
particular
about it.
stat, right? Or even like an unreachable record, like Tiger's record of consecutive cuts made. Every time I look at that blows me away.
Yeah.
That seems
That's a huge
far
one.
and away beyond something that anybody else could even hope to achieve. Like it's ridiculous, right?
Yeah, that's probably one of his top. Mark Brody talks about a stat which I think is great, which is he created a stat called beat the field. So, did you in this round beat the stroke average for that day, right? So, if the field shot 72 on average, did you shoot better than that? And he beat the field on something like 80 consecutive rounds, which is just crazy. To not have one, his off day was still better than more than half the field.
Yeah.
So, yeah, I mean,
I think I've lost to the field on weekend tournaments at that kind of rate.
That's
but I
awesome.
do. I love that. And obviously, tennis is having a moment right now where you've got three guys still playing who are probably the three greatest tennis players of all time. And so you can have this active debate about Federer, Nadal, Djokovic of the male sides. On the female side, Serena's right up there in that conversation with Steffi Graf or Margaret Court. But I'm kind of a big believer. It's really hard to compare different eras, right? It's hard to compare. I just read the young Tom Morris biography, and what he did for golf in the 1870s and 80s was unbelievable. And he was the Tiger of his day, and he won 4 Open championships. But how do you compare what he was doing to a sport that's unrecognizable to what Tiger's been doing in the last 30 years. But he was the best of his generation by
So let's do one more.
All right, I'm in.
Let's do one more. We'll keep it in the same era. This one fascinates me. Ronaldo or Messi?
Ooh.
That's a great question. That's a great question. It's almost impossible to separate them. I would say if I was the manager of a team and I could pick one of them to be on the team, it would be Ronaldo because I think his range of things he could do, even now, but at his peak, was a greater range of things. But Messi was probably the most skillful footballer of all time in the way he dribbled and passed, and he still does. Obviously, he's still going. But is that suitably on the fence? I probably would favor like having Ronaldo on my team because he could do everything. But there probably are
I think that's
the
fair.
two greatest players of all time, maybe, at least two of the top five of all time. And you can't leave out people like Pele and Maradona. And selfishly, I would put George Best up there, even though outside of the UK, he's not that well known. I could go
The
on for
hand
hours.
of God. The hand of God.
Yeah, I'm somewhat biased
That's right,
against Maradona for that. But you watch the other. If anyone wants to go and look up,
Still makes the list.
look up the Hand of God goal in 1986 World Cup, and then look up his other goal in that game, and he beat the entire English team and then scored. It was the two sides, the yin and
his
yang
own.
of
Yeah.
everything Maradona was, the good and the bad.
And on that note, Tony, find us out there. Find us, follow us, Golf Spy T, Golf Spy C, Paul Wood, Ping Engineering. Drop your questions, drop your thoughts. If there's a club you want Ping to design, if there's a bizarre ass test you want Ping to run, they probably will. I guarantee you this, they'll at least consider it. So on that note, let us know what you think. Talk to you later. We out.